Okay, welcome back to the next video. In this video, we will see the Gibbs phase rule. Okay, phase rule is very much important in determining several factors in the phase diagrams. Before moving into the Gibbs phase rule, let us see some of these parameters. Okay, first we want to see the physical properties. Okay, physical properties are basically classified into two. The first one is intensive property. It is also known as bulk property, and second is an extensive properties. Okay, the intensive property, which means that the physical property of a system that does not depend on the size or the amount of material present in the system. Okay, and all those physical properties are categorized under this intensive property. Some of the examples of the intensive properties include the temperature. We know the size does not depend on the temperature. Similarly, the pressure, the refractive index, density, and hardness of any objects. So these factors does not depend on the size of that particular object. Okay, so next is the extensive property. Just opposite to the intensive property, it is those physical properties of a system that depend on the system size or the amount of material present inside the system. Example, like the mass, volume, entropy. Because if size increases, the mass increases, the volume increases, also the entropy also increases. Okay, so the next property we are going to discuss is the thermodynamic variable. Okay, the thermodynamic variables basically are the pressure and the temperature. In most of the cases, the pressure is fixed, so hence the temperature will be the thermodynamic variable. So one factor, like one fact we need to understand is that this thermodynamic variable will come under the scope of intensive property itself. So like in order to explain just but this refractive index is an intensive property, but it is not a thermodynamic variable. So that is why it is separately categorized here. So next is the composition variable. Composition variable includes only the phase compositions, which are considered as a variables. Okay, so now let us see the Gibbs phase rule. Gibbs phase rule was first developed by Joshua Williard Gibbs in 1875. He published it in this paper titled On the Equilibrium of Heterogeneous Substance. If you check the Google Scholar, you will get his paper even now also. So this is published, which is considered as a general principle governing the systems in a thermodynamic equilibrium. Okay, and it is named as the phase rule. Mathematically, it can be represented as P plus F is equal to C plus 2. That means the P is the number of phases of a material, F is the number of degrees of freedom, and C is the number of component of a system. So and here 2 is there. 2 represent the two variables, that is the pressure and temperature, or it is the thermodynamic variables or the intensive property or intensive variables, you can see. So here coming to this one, the phase and component, actually I'm not going for the explanation because these two concepts you have already discussed in the previous slides. So here the degrees of freedom is the new one. So degrees of freedom is represented by F. So let us see what it is. It is the number of intensive variables, okay, that are independent of each other, does not depend on each other, or in other words, the number of thermodynamic variables which can be specified independently without changing the phase of the equilibrium. Okay, so like in a binary phase diagram, there are two component system, we know. So these two component system here, in most of the cases we will keep the pressure as a constant. So therefore only we will consider only the temperature as the one factor. So here this 2 will change into 1. So we will put it as P plus F is equal to C plus 1. So this is the Gibbs phase rules deals with. And in the next video we will move to the one of the important area of our material science and technology, that is iron carbon diagram or iron carbon phase diagram. So thank you for the attention and see you in the next video.